question about linear and exponential functions, and in this video we're going to focus on graphs. We're going to compare and contrast the graphs of both a linear function and an exponential function, and we're going to pick out their key elements so that we can write the equation that goes with them, and then that would allow us to make predictions based on the graph that we're given. So let's jump in and look at a couple of graphs. Now you probably remember that the graph of a linear function is a straight line, while the graph of an exponential function has a curve in it and it flattens out on one side of the graph, okay? So this would be our exponential function. You see it's flattening on the left and going up very quickly on the right. And then this is our linear function. We have a straight line going on. So let's focus our attention first on the linear function, okay? This is a graph of a linear function. And from the graph, we can pick out some key elements. We can look at this and say, okay, well, there's a y-intercept. That's where the red graph crosses the y-axis, right there at 3. So we're going to calculate the slope by considering the rise and the run. Okay, so the rise and the run, we're going to look at the change in y from one point to the other, and then the corresponding change in x. I'm going to start, in this case, with the left-hand point. Notice that we are going to rise 2 units. Okay, and then from there we're going to run 3 units. So that means my slope is 2/3. And with my slope and my y-intercept, I can write my function. I can say that my function is y equals 2/3 x plus 3. Now if I'm looking at an exponential graph, it's not quite as straightforward, but it's not terrible either. Okay, so we can first look at this exponential function and identify the y-intercept. Now here we have the y-intercept as 1/2. All right, and then to find the multiplier, what we really need to do is consider what are the y values for consecutive x values. Okay, so now let's think about what is the y value when x is equal to 0. Well, we just picked that out. That is the y-intercept, so that's 1/2. Now, how about the y value when x is equal to 1? Well, x equals 1 here, y is equal to 1 as well. Since I know this is an exponential graph, I know this is going to have a multiplicative relationship. So what would I have to multiply 1/2 by to achieve 1? Well, that I would be multiplying by 2. Now let's double check and make sure that that multiplier holds with these next two x values. At x equals 2, y is 2. Well, is 1 times 2 2? It surely is. Let's try one more. At x equals 3, y is 4. And when I look at that, that also holds. My multiplier is 2. So now if I'm considering the equation of an exponential function, we know that y is equal to a times b raised to the x, where a is our y-intercept and b is our multiplier. So I can sub those things in, and now I have my function. All right, so now let's look at a couple of examples where we're just given a graph and we're asked to find the equation and then a function value that's not on the graph. So when I'm looking at this graph, I first want to decide, is this linear or exponential? Okay, so we know that this is not a straight line. We know it's got a curve. We can't really see where it's flattening out, but we can kind of guess that it's flattening out here on the left. All right, so we can say, yeah, this is an exponential graph. I remember that my exponential function is going to have a y-intercept, right? And we can say that the y-intercept here is 3. And then I'm going to need a multiplier. And so for the multiplier, remember I want to think about some consecutive x values and their corresponding y values. When you're doing this, you're going to need to look at the graph and find some good x values. Now you can choose anything you want, but I'm not really sure what the value for y is right here or here. So this looks like it's right in the middle, so I'm going to use -1. I definitely know what the y value is for x equals 0, and I can see what the y value is for x equals 1. So when I fill those in, I can see that the y value is doubling. We're multiplying by 2. So my multiplier is 2, my y-intercept is 3. That means that I can fill in my function. So my function is f of x is equal to 3 times 2 raised to the x. I've got the equation of my function, but now I want to find f of 5. And the way I do that is I just sub in 5 wherever there was an x. Okay, so here and here, and then evaluate. So 3 times 2 raised to the 5th power, which is 3 times 32, also known as 96. So f of 5 is 96. Okay, let's try one more example like this. Oh, this looks like a linear function, right? It looks like a straight line. Okay, so let's identify our y-intercept. And again, our y-intercept is 3 here. And now let's look at our slope. Okay, so pick out a couple of points that are on that line. Be good to yourself. Pick out some points that are easy to count from. All right, and so from the left-hand point to the right-hand point, we're going to go down 4 and right 1. So our slope will be a -4. So with a -4 slope and a y-intercept of 3, I can write my function. And my function would be f of x is equal to -4x plus 3. Now to find f of 5, remember I'm just going to sub in a 5 wherever I see x. So f of 5 is equal to -4 times 5 plus 3, which is -20 plus 3, which ends up being -17. Okay, in the next video, we're going to talk about written descriptions or verbal descriptions of linear and exponential contexts. So I will see you there.